what's up, guys? Oh, what the fuck? Alright. Wait, do I still have Pokeballs? I totally forgot. Yeah, I got Pokeballs. Oh, and in case you're asking about the rare candies, I put them in so I don't have to keep grinding for levels. Okay, burn. Alright. Ah. Oh. I think Paralysis in Kaizo actually got a buff. Like, I think it's still like... Is it still 50 or 75% now? I forgot. And the AI come out with the confused paralysis strats. Holy shit. Oh shit. Let's see what do they put in this route in Kaizo? Eh. Oh, by the way, guys, feel free to ask me any questions. I'm just chilling out here until 8 p.m. I actually haven't found anything that difficult just yet. I know Roxanne's what's called Pokemon are at level 15, so I'm really hoping that I don't surpass the level cap by the time I get to her. So, wait, do I go left or right? I don't battle this guy. Okay, goddamn, I have to fight this guy. Maybe I should catch some Pokemon so I don't surpass the level 15 cap when I get to Roxanne. Oh no, another trainer. think if Torchic kind of faints, then it's fine. I'm not playing this on hardcore Nuzlocke, by the way, so... and the Nuzlocke rules are if... what's it called? If someone actually, like, faints, you have to release them. So I'm not playing on those rules. I have not done any Nuzlocke challenges. I'm just doing the soft level challenge. Oh, sweet, hit the confusion. Oh wait, am I gonna lose? What the fuck? Oh, I hope not. Yeah, these AIs are actually giving me kind of a challenge, so goddamn. Like, I think I have like both my Pokemon under like 6 health or something. So like, if you're familiar and you've played with Pokemon before, like, you'll know like you can usually generally just put your starter in front and just sweep. But unfortunately, Kaizo just literally just makes this really, really freaking hard. Oh wait, what the fuck? No, 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 not like this, not like this. Not like this! Not like this! Not like this! I didn't even know this was gonna come! Alright, you know, we're not losing like this. Holy shit, we're not losing like this. Screw it. I'm gonna heal up and then I'll do that battle later or something. My friend is a senior mechanical engineer and he works as a data science intern. He wants to switch to software engineering to a big tech company, but he has no years of experience with software engineering. Any advice? As long as he's got like some kind of programming experience, he'll be fine. Because that's really all they care about at the beginning. That you at least worked on with some kind of what's it called, software and programming. And then after that, they can probably like level you at like L4, because at that point, what they really care about is the fact that you can actually write code and, you know, write product. So it's like giving you an independent task and being able to complete it. So that's fine. Like, we'll probably level you at an L4. Oh, but if he works as an intern, data science intern, yeah, you can just make the switch to Sweet. It's possible, and we just do an L3 loop. I thought you said he was like a senior or something. Okay. Anyway, you know, I'll do that battle later because that caught me off guard. But notice, like in Kaizo, it gets so much harder. I have no idea who created Kaizo, but like, holy shit, that dude has like a mind of a fucking sadist. Senior in college. Okay, I thought he was like a data science senior engineer, so... Yeah, he'll be fine. He can make the switch. Let's see. Oh, 350. Okay, I feel like this data got bumped up like in recent years. Like, it used to be like 300 or something. Now it's like 350. It's kind of interesting. Let's see, filter... in the past 2 years, yeah. Wait, does the salary range not change if it's... Yeah. Oh, you still... Okay, this is probably like MLAI stuff. Android 547, this probably is like some technical lead. No. Alright, it's 8 PM, so let's bring up my client on, let's see what's up. Hello?
Hello.
What's up?
So, no, I mean, nothing much has changed since last time.
Okay, that's fine. Let me pull up your sheet. Give me a sec.
Yeah, for sure.
So your prep docs here. Yeah. So when we talked, you mentioned that you have you had a little bit of mistakes, be a little bit more meticulous. And then yesterday we talked about you weren't able to really do much, but you got a little bit better at writing your what's it called? Practice diary entries.
Yeah.
Were you able to do any problems last night or
Yeah,
today?
yeah, I did like a couple problems, and then I watched the videos for them, and then I created my deltas.
Mm-hmm. Did you?
The most recent question I didn't get to watch the video, but the other questions I was able to. I think I'm a bit better in my delta. I still feel like the majority of my time comes from debugging, according to what I see in my videos, uh, which is kind of sucky, I guess, that I
Yeah.
spend the majority of my time debugging for the entire solving the code. But the
Mm-hmm.
main idea is more or less okay.
Okay.
It's just that the debugging part gets me. Sometimes, like, there's a little tiny error in my idea that I might have caught beforehand, but I didn't really remember it
Okay.
too well, or I completely missed an idea. I mean, a test case in my idea, and then I have to go back and change it.
Mm-hmm.
Or yeah, like some of my ideas are just plain wrong, sort of thing. And,
Okay.
like, those are usually just the two cases.
Got it. I'm guessing row 169 is the one that you're talking about.
For
You're the one where you said, "Hey, you ran into a bug."
yeah. I mean, yeah, I ran into the bug. I ran into that bug there too. It was a memory error thing. I remember doing this question before with you. I had like a really similar error, which
Okay.
really was sad. But
Yeah, but if you're running into similar errors, then that means that you're obviously you have to compare to the last time you did the delta, last time you did your diary entry, and see if it's the same mistake or different mistake.
yeah,
Okay, so let's see. Put a clarifying question, more example. That's fine. Ask high level idea, inefficiencies, testing, ran. So prove efficiencies. All right. So when I look at this, you passed in the wrong argument values, and you spent 6 minutes trying to figure that one out. Is that what I'm
yeah.
getting here?
That was one of the bugs. Yeah.
Okay. How many bugs did you make here?
I think the only other bug was while I was debugging, I introduced another bug.
Oh.
So it was more like, yeah, it was essentially the main idea was passing in the wrong argument values, but I introduced other bugs while trying to fix my current bug.
Okay, that's very bad.
And then after that, I realized, oh, it was right the first time. I just passed in the wrong argument values, and then.
Okay, so which means that all right. Let's see why. Let me read your delta then. To want a value to persist through recursive call, utilize an array.
I mean, that was an idea, like, memory-wise, like, because I wanted to pass in just a primitive value, but I wanted to persist throughout all my recursive calls.
Why not?
I wanted each recursive call to have the same value.
Why not just? But why not just use a global variable?
Oh, I was considering a global variable, but I didn't really know how to initialize one in just a method. I tried utilizing just a global variable for it, but then since it's not in a class, so I couldn't do like a this dot.
I don't understand why you can't just do something like I don't know, like value equals 2 outside the function block.
Yeah, I tried that initially. I think it's just me not understanding memory too well, because I tried like the previous value. I tried setting previous to like negative infinity outside the function block, but it still didn't work.
So in other words, this is so you came with an answer, but this looks very wrong. The fact that you have to pass in an array like that looks very wrong, actually.
Yeah, it does look very wrong, but it was my substitute, my workaround to not being able to initialize a global value.
But that means that you should learn how to initialize a global value in Python.
Yeah. Okay. Yeah.
That's basically what you're talking about. And so previous value equals 0 root data. Okay.
Yeah, that just me setting.
So does that mean that when you pass in the next value, that it's going to be root data?
Yeah.
So why? But then you're making it But then because it's a reference, this would affect it everywhere, right?
Yeah, because it would
Oh.
affect it everywhere. Yeah.
Yeah, I don't understand why you can't just do like define it outside the function and do. You have to look up how to do a global variable in Python. That's basically what
Yeah.
this boils down to. That's the
Yeah.
first thing, and the second thing, um, yeah, what other bug did you make?
Um, I think the other bug was just me messing around with the previous.
Okay.
So it was just like, yeah, it was just me messing around with the previous variable. Like, oh, should I try this when modifying the previous variable, modifying that when using a previous variable?
Okay.
So yeah, nothing too major.
So
But the main,
are you sure? Because to me, the fact that well, for one, let's look at this like I'm the interviewer, right? I
Yeah.
see a guy who walks in, does Python, writes Python code, can't declare a global variable, and then he decides,
Yeah.
and then he introduces more bugs while debugging.
Yeah.
So what do you what do you think the questions you should ask yourself are when you're doing the delta then, from that perspective?
When doing the delta for this, I would probably, I mean, first of all, it would be try to learn how to use a global variable and how to initialize it.
Okay. Do you know
That's
how to do it
one.
now?
I think I have an idea of how to do it. Like,
No.
I know in
no,
classes,
it's either you
yeah.
know it or you don't. You either know it or you don't.
I know how to do it with classes. If the function is embedded within a class, then I know how to do it.
Why not?
Outside of, if it's just a normal function, I think I have to define it outside. I know I have to define it outside the function, but
So
I
why
have
don't
yet
you do
to
it?
find out.
So you know what the problem is. Why not actually learn it so that way you don't have to it bite you in the ass in the future?
Yeah, that's true. Yeah.
Yeah. So in
I
other
thought-
words, you identified it, but you did nothing about it.
Yeah. Okay. Yeah.
No, that's it. There's not really an excuse. Like you know what the problem is, just fix it and just learn it so it never happens again, right?
Yeah.
So I don't know what's going on here. So it's like, yeah, I don't know. So okay. Other thing, the second thing I would think of is, hey, this guy's introducing bugs while he's debugging. Why did that happen?
Yeah. I think it was a little bit too panicky when trying to debug the code because like okay, my ideas is like seems really simple. I don't know what's going on, and then I know that I follow the idea generally if you disregard the variable passing thing, but I just need to try and figure out if I am passing the right variables sort of thing. So I try out, hey, what happens if I try passing in this value instead, or messing around with the order of the functions.
Okay. No, so that doesn't make sense because that just means that how does that relate to panicking?
I mean, that was, I guess, I relate it to panicking because it's more like I'm trying random things rather than following a logical order of steps of walking through the code and stuff.
Okay, so you said you followed the idea correctly, and it boiled down to you not knowing how to declare a global variable. So the question is, did you identify that it was because the global variable didn't work? Or however you did it?
I mean, instead of, I didn't exactly state the global variable, I said utilizing an array instead, and then I adjust how I can improve my, lessen my debugging times.
I don't understand.
Like, how to spend less time debugging. So try these steps when, knowing when you know this certain information, try these steps for debugging instead.
Okay. So what are the walk through each step after confirming the code follows the high level idea. Okay, the code did follow a high level idea. So in other words, it's a mechanical issue.
Yeah.
So to me, just fix the mechanical issue and you should be fine.
Yeah.
So and yet you tell me, oh, I have some idea, but you never tried fixing it. Like you never actually tried confirming that if that idea works or not. In other words, you just made it up.
Yeah. Okay. Yeah. I mean, okay. I'll go after this and go try the question again with the global.
No, not even. Just figure out how to write a global variable declaration. Just do like hello world or some shit, and that's it.
Yeah.
Yeah. Even try. Yeah. Sure. Go ahead and fix it afterwards as well. But that's what I mean by being meticulous about your details about getting better. It's like you know what the problem is. You know that you're gonna need to do it next time. It might come up again. Why not just spend the time now to actually get it out of the way? I don't know why people do that. It's like, oh, I know what the problem is. and then they just and then we'll do it next time. It's like, no, why not just actually try it out now, and then so that way you know what it looks like.
Yeah. Okay. Yeah.
So I don't know. The next one, I wonder 68. You said you couldn't come up with a solution.
Yeah, I haven't watched a video for that one yet. But essentially, I was really like, I didn't understand how to come up with the solution to it. Like, it says, okay, you have to find a salary cap.
Okay.
Hmm?
Salary threshold. All right.
Yeah. So essentially, like, okay, like your company needs to implement a salary threshold, so anyone above the threshold needs to be paid the threshold, right? And then I was just trying out like ideas, like, okay, maybe I can try, maybe like, okay, what happens if our order is in a neat way? How do we exactly calculate a threshold in the first place? Like, no matter what we do, doesn't matter the order. Like, I just tried how to solve getting a threshold. I couldn't solve, like, how would you get a threshold in the first place?
Okay, so let's read the question. You're working in a finance office for a corporation. Yeah. Corporation has to cut payroll expenses to a target. Wants to do this by putting a cap on last year's salaries. Every employee who earned more than the cap last year will be paid the cap this year. Okay, so in other employees who earn no more than the cap will see no change in salary. So the example, they say, hey, yeah, if the target payroll is 210, then 60 would be a cap because of you have 90, 30, 140, and 20. So the person making $90 gets reduced down to 60. The person making $100 gets reduced down to 60, right? So you're saying you don't know how to come up with a solution.
I couldn't come up with, like, yeah, the brute force was okay, but like I couldn't implement the brute force because that was too big of a time complexity sort of thing.
Yeah. But you should at least come up with a brute force solution, right? So what is the brute force solution?
Yeah. I mean, it's basically from every number from 0 to the target payroll that they give us. Like the target that they need to reach, basically iterate from, try every possibility from 0 to that number, like the cap that we have, and check if that number is a suitable salary cap.
Yes.
Yeah.
Okay, but what's the inefficiency there?
We don't really need to iterate from every number 0 to target payroll.
Right, so what can we do? So how do we reduce the numbers that we need to search for?
Reduce the numbers we need to search for. So, I mean, what we can do is maybe we have to narrow down the values we need to iterate over, that's for sure. But how to do that, I think an idea is essentially, okay, if we have a certain value that works, we know that all the values after it will work, and all the values before it won't work. So then we can try to, like, okay, all the values after it won't work.
So let's say I get if for this specific example 210 and 60. Let's say that I put a salary cap of 50.
Mm-hmm.
Would that work?
So for the numbers, like the example numbers, like 20, 30, 40, 90, 10, 100.
Yeah. If I made, instead of a $60 salary cap, what about a $50 salary cap? Would that work?
Yeah, that would work.
So I don't know what you mean by before and after. That just...
Yeah, my bad. I meant numbers before, the numbers come before the, in like the number line, like 0, like if 50 works, if like 60 works, then every number before 60 works, like 0, 1, 2, 3, 4, 5.
Sure.
Is what I meant.
But the thing is that there might be some numbers after that, like that are greater than that.
Yeah.
Greater than after, before and after means nothing. Greater than or less than means something. This is what I mean by just having enough details. Just that one word switch makes all the difference.
Okay, yeah.
Okay. So, yeah. In other words, you can use...
Oh, I can use... I mean, I know an idea is binary search. If we sort all the salary numbers that we have.
You don't need to sort the salary numbers. You just need to sort the payroll.
Yeah. I mean, no, the payroll is just a number. The salary is like what they give us.
Okay. Yeah, so you're looking for basically a binary search on all the numbers between 0 and 210.
Yeah. Essentially, yeah. And then target, if we binary search on the payroll, that payroll. Well, yeah, okay, yeah. And then that payroll, we try to see if that's a suitable salary cap, and then if we try and find the biggest one that's a suitable salary cap, yeah,
Yeah.
by binary searching.
So that'd be a log n on the time, and then and then times x, because you have to iterate through every single salary and then put a cap on each one and try it out.
Yeah.
So that's x log n or whatever it is. But you see, like that's the logic, right? You should have immediately recognized, hey, I have a number line, right, for 0 to the payroll target, and I am going to do a binary search on that because of this rule of, hey, well, if it's less that if I get a suitable salary cap, then the numbers less than that are obviously going to be suitable, but the numbers greater than that may or may not be. So if I wanted to try and do the exact salary cap, then I can do a binary search. I just have to split into left side, right side. I can eliminate the left side because I already know that it's less than. But then if it's like, if I end up with a salary cap that's greater, then I can eliminate the right side because any number greater than, in this case, 60 is not going to be suitable. So anything greater than 60, we get rid of. So this is where you should recognize the binary search pattern.
Yeah, okay. Yeah, binary search. Yeah, I don't know why I didn't think of binary search when doing this problem. I think it was because when I initially think of a precondition that binary search is searching on a sorted collection, like an array or a list. But I didn't really think about binary searching over a list of numbers because I didn't explicitly state that it was a list of numbers. It was just like a numbers that I iterated through.
It's an array of sorted numbers, right? A number line is essentially an array of sorted numbers.
Yeah, I didn't make that connection for the number line and the sorted list of numbers.
Okay, well now you know.
Yeah.
That's the thought.
Write that down really quick.
I mean, I don't even look at the answer. I don't even know. I just went through it step by step, right?
Yeah.
So it's like you said, trying to think of some algorithms that utilize proper binary search if stuck. No, it's about recognizing about recognizing what is already sorted and given to you. In this case, number line.
Yeah.
So
like, I tried coming up with something like maybe let's try the average or something of the salaries. Would that help us gear towards a solution? And then I just spent time wasted there.
Yeah, it's like there's no logic or reason behind it. So you're trying moonshots. This basically means that you've given up on trying anything sensible.
I mean, the average was more like, okay, if everyone gets paid equally, would lower the overall salary, but I didn't think it through to actually pan it out too well because like I had no other ideas to go off of.
I mean, to me, when I look at a problem, there's like certain levers, like the initial solution is just try every number between 0 and 210, right? That's a lever that you can push. Another push is like the salaries themselves. So there's only two levers that you can push, and if it's not obvious that you can do anything with the salaries themselves, the only other lever that you can move is the search between 0 and the target payroll.
Yeah. Okay, yeah.
So, I mean, it's about accepting the situation for what it is. And you just kept doubling down on the salary when it was very obvious that it's not obvious at all. And you ignored this other...
the more obvious thing that's target payroll, yeah.
Yeah, so it's like knowing what your options are and then using them.
Yeah.
So, anyway, that one would have gotten you definitely killed on a interview. Alright, anything... Let's see what else you got. Is that it? I noticed row 167.
167? Oh yeah, that one. That took quite a bit of time. Basically, I think the idea was right? It's basically I have to implement a sorting algorithm for a linked list, essentially.
Fast sorting for lists, okay?
Yeah, it was essentially implement a sorting algorithm for lists. I wrote out the naive solution. Well, wait, let me explain the problem a little bit first.
I mean, I have it right. Implement a routine which sorts lists effectively. It should be a stable sort, i.e. the relative positions of equal elements must remain unchanged. In what respects are lists superior to arrays? Okay. So implement a routine which sorts lists efficiently. Okay. So then my question to you is, what is walk me step by step through it.
So naive solution is, essentially we copy all the values of the linked list to an array. We utilize the built-in sort function to sort the array in ascending order, And then after that, we just iterate through our array, making a new linked list out of the array.
Sure, why not? Okay.
Yeah, that I mean, it works. Because it's not really well because we don't really need to copy all the values, and especially since it's a linked list, we can start reordering values in our linked list
Mm-hmm.
instead of making an entirely new element, entirely new node for each element, because in real life sort of thing, those nodes could be like really complex objects that take a lot of time to copy over, so you probably don't want to do that.
Yeah.
So then I tried looking at other types of sorting out, like I tried looking at types of sorting algorithms, like to see which one would be good for our situation. I tried looking at heap sort. It sorts in place, but it's not really stable. Quick sort is also not stable, but it's pretty good. Like I just listed the n log n algorithms that I know for
Wait, is
sorting.
quicksort the one with the pivot?
Yeah, it's the one with the pivot.
Yeah, I feel like is it really not stable? I could have sworn it is.
I mean, pivot basically you don't really order all the elements. You just partition the elements from from your pivot to your left is all the items less than.
Right.
To your right is all the items greater than. So there's no particular order to how you can do it there.
No, but then as you keep going, you just go through the rest of it, and then you'll eventually get to the sorted value. So lists allow you to do things in memory, because all you have to do is just really change the. If it's a linked list, then all you do is just change the what comes next. Right.
Yeah.
So then when you say list sorts lists efficiently, the relative positions of equal elements must remain unchanged. Okay. All right. So you say it's not stable. All right.
Yeah, I know. I think I read about it in like the boot camp for the sorting chapter for EPI. That quick sort is not stable, so I think that's where I got the idea from.
Okay, sure. I mean, I don't.
But yeah,
honest,
anyway.
I don't remember that.
Huh?
To be honest, I don't remember that shit. So okay, I'll take your word for it.
Okay. So yeah. And then after that, I came up with merge sort, like the one that they basically teach you everywhere, sort of thing.
Yeah.
So merge sort, that's stable, because it makes the relative items equal to each other. It makes the items equal to each other in their original. It sorts the items in their original order. A stable sort, essentially.
Okay.
The relative positions of equal elements remain unchanged.
All right, that's fine.
So yeah, and then I went into how would I implement merge sort. So I generally knew the idea for merge sort, but I wanted to explicitly state it out. And I didn't want to deal with linked lists right away, so I was like, you know what? Let's implement the idea for an array first, and then convert that idea to sorting for linked lists, because essentially it's the same idea. It's just some implementations are different. So I put at the high level of merge sort. So as you see there, there's a high level merge sort, and then now I tried converting it to linked list, and then basically was what it is was what I had to convert from array to linked list was essentially finding the middle point of the two linked lists. And then I tried out the examples again on merge sort just to make sure I actually have the idea right. And then I tried it again to make sure I had the linked list idea right. And then like I basically walked through the entire example, like even the recursive calls sort of thing. So I walked but it was just a small list, like of 4 elements, so it didn't take too long. But after that, I was like, okay, let's start implementing the code. And then when I looked at the code, when I was initially developing the code, I was like, to make this a little bit simpler, like to instead of using like 2 pointers, slow and fast pointer to find out our middle point of the linked list, then why don't I make this a lot simpler by just calculating the length beforehand and dividing that by 2? Because essentially what we're doing is dividing by 2 either way.
I'm gonna stop you there because I'm gonna say that you just bored the shit out of me.
Yeah.
So in other words, you gotta get the idea down, get it fast conveyed, even in normal speech. Like I just zoned out like 3 minutes ago.
Okay,
So
yeah.
So
basically, yeah. Basically, after that I went into implementing merge sort. Merge sort came into difficulties because I tried to simplify my code before actually trying out the original idea that I did test out. Because I thought the simpler idea.
What's the point of what you're saying? What's the point of you telling me this? Let me ask you that.
Because the simpler idea caused the bug that I had
Okay.
rather than following my tested approach. Because I thought the simpler idea would also be like would pass the same test cases that the more complex approach would work at.
Okay. Did you test the idea before you did it?
I tested the complex idea, but I didn't test the simpler idea, so that caused me a little bit bugged there.
Okay. So that's really what you're talking about. It's not the fact that it's simple that caused the bug. It's the fact that you didn't test it.
Yeah.
So in other words, the lesson you should learn is to test your design before you commit to it.
Yeah, I think I wrote that in my delta as
Let's
soon as
see.
I can.
Remember to follow design. Yeah, make sure design easier. Yeah, I think we mentioned that before. Look at the design, and know what steps. Yeah, don't do the shit in your head. We mentioned that before. Quick check of design doc does not hurt for typos. Yeah. Sorting object, make sure sorting object does what you do. Explicit sorting criteria. Wasting time thinking about the sorting function. Save time. Thoroughly test all the possibilities. Yeah. So okay, that's pretty thorough. So make sure that you do all these steps. Like just double. It just means double check that the variable names that you got going are fine and to test it. That's the takeaway.
Yeah, like basically after every modification, I should go back to the drawing board again, just make sure.
Yeah, I think we literally had that the other week.
Yeah.
So in other words, you've made the exact same mistake. So
yeah,
so that means that you are doing something wrong. If you made the exact same mistake and you're still doing it, what's going on here?
I think because last week it was I was trying to convert to a more complex idea, but this time I was trying to convert to a more simpler idea that caught me off.
Okay, but even then, the underlying fundamental principle is the same, where you changed your idea and you still didn't test it. That's a problem.
Yeah.
You made the same mistake. We only make mistakes once. We never make mistakes again. And you made the mistake again, which means something went wrong in your approach.
Mm-hmm.
So what happened? When you practice, do you think about the mistakes that you've made? Do you remember the mistakes you make?
Generally, for most mistakes, I would address them. It's more like for this one, it's more like okay, after every change in idea, even if it becomes simpler or more complex, I would try the same test cases I did for the original approach to make sure it still works.
Okay, and did you do that here?
Not here.
No, there you go.
Unfortunately. Yeah.
All right. So again, like you made the same mistake, so hopefully you never make this again.
Yeah.
Like it's like if you still make the same mistake, then the chances are that you're not paying attention to it or watching out for it. It blew you up. It blew you up once before. If you step on a landmine and it blows you up and you blow off your left leg, are you gonna go walk into another landmine?
No. Yeah, I think like generally because I need to make sure that I can remember all my mistakes. I don't make them again. It's just sometimes maybe I forget, which is really
It's not active. It has to be like ingrained in you, burned in your mind. The mistake has to be so bad you never want to make it again. So the only the way I describe it is that you literally need to think I'm yelling at you and telling you fucking suck for making this mistake, and you need to be like scared shitless. That's the. I'm gonna tell you this. I don't actively think about every single mistake I make. I'll tell you this. But I make an instinct of it, and I will definitely recognize it when I'm about to make it. I can't tell you all the mistakes in my head from my head, but I can tell you definitely what mistakes I have what mistakes I've made, and then the rest when I recognize the situation, I'll probably be able to tell you, hey, yeah, I've made this mistake before from this problem.
Okay, yeah.
Yeah.
Like generally, go.
That's the attitude you need to have. Literally, every mistake needs to be so bad and so painful, you never want to make it again. It's not just paying attention to it. It's knowing, shit, I am making this mistake again and again. I feel fucking terrible. I never want to do this again. You know?
Yeah. I think one of my problems is I make the feedback too specific to the problem rather than more generalizing it. Like, in this case, it was, my specific feedback was, okay, when converting from a complex idea to simpler idea, test the code. But essentially, the more generalized idea was to test the idea after every idea change.
Yeah, like in general. Remember what I said before? It's about refining your approach in general.
Yeah. Like, I think the majority of generalization I usually get is, okay, for these types of problems, try thinking about this certain variable, like these certain situations.
Yeah, and that's the problem. Oh, memorize this fact, memorize this fact, memorize this, that, memorize that. No. It's one general principle that should always follow you. So that way you only
Yeah.
carry around like a handful of them instead of like trying to memorize four. It's like the problem with memorizing 400 leak code problems and their solutions is that you're not gonna memorize 400 leak code problems and their solution. And it's like a little bit better at least if you remember the situations for your approach. But why not just follow a few general principles for your approach?
Yeah.
And
And
then
that
you
makes
realize,
everything
hey, I
more-
made this mistake before. Da 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 da.
Yeah.
So that's I don't know how to help you on that other than for you to keep doing it and for you to really be hard on yourself when you make those mistakes. Now, how hard you want to be is going to be up to you. I can only point it out. I can only say, hey, you can never make this mistake again. But how hard? But ultimately, it's going to come down to how hard you are on yourself.
Yeah, for sure. I'm gonna need a lot more practice with the more questions to ingrain that idea.
It's not practice at this point. It's really just how much pain are you willing to put yourself through so that way you never make the mistake again. You're already up to 160 problems. I don't even did I mean, let's see. I think M only got up to like, yeah, he got up to like 240, but that's like over 4 months. Yeah, I mean, you're getting there. You're pretty close to the amount that M got to before he got like really proficient at this.
Yeah.
So it's gonna click for you, or it's not, depending on how much how hard you are on yourself.
Yeah, for sure.
So it's an attitude thing. That's all I can say.
Okay, yeah. Hopefully, my attitude is getting a lot better towards these problems when I start doing them.
A little bit better. It's a little bit better, but I mean, there's still a little bit of the attitude thing is almost always like 80% of it when I'm dealing, especially when I'm dealing with like new grads. It's like, hey, you gotta be more specific. You gotta be more specific. You gotta really hammer down details, and they don't understand what I'm talking about, and they think it's enough, So it's like you're facing the exact same problem everyone else does, and there's no way for me to convey that other than for you to keep screwing up so much, and for you to really feel the pain of it. And that's pain's a great teacher, but I can't. There's a limit to what I can do.
Okay,
Anyway.
yeah, I understand.
Anyway, let's do it. Let's do a problem.
Okay, yeah. Let me get to the problem sheet.
Okay. Oh wait, hold. Okay, let me see.
So,
All right, wait, hold on. Let me get another white claw. Give me a second.
Alright, yeah, no worries. Whew.
All right. Okay. Okay, which problem should I give you? Actually. Let's see. We could do the serialize and deserialize problem again, actually.
Okay.
Okay, let's see how well you work through that one. I'm curious.
I mean, I never did it before, so
Serialize
yeah.
and deserialize an array tree? I feel like we did it before.
No, I mean, we haven't done it before, but I have, like, I remember a while ago, I remember watching one of your video on serializing and deserializing a binary.
Alright, so then let's see what your approach is. Ready? Let's see. And here we go. So I want you to serialize and deserialize a general n-array tree.
Okay. Okay. So that's an example. Let's read it out first. So A has children B, C, D. B has children E and F. F has child K. D is up here. Okay. I, G, H, J. So I'm guessing serialize means just put it in a like a string that you can easily identify the tree, the NRA tree, if you deserialize it.
Sorry, what?
So does serializing mean putting like the entire NRE tree in a string that
Yeah.
you can easily deserialize
Mm-hmm. And get that and
uh,
get back
and
the
get the same tree?
get back the tree structure. Yes.
Yeah. Okay. Um. Okay. So I know that we need a way to identify when it's a child, and when it's a child, and the children of those child. Okay. Let me draw an example. That sounds a bit weird.
Mm-hmm.
So we need to identify a way to identify A is our root node, and then we need to find a way to just have like identify the children. So like BCD would be the children in this case of A, and then we also needed some way to identify that the children of B also. I guess we could try putting EF here, but it would be kind of difficult to identify if it's a child of B, C, or D. We
Okay.
could go from left to right, but that would be a bit too awkward.
Okay.
But what happens if we try putting it into here then?
Okay.
So then it's basically you have B, and then if it has a bracket, like you identify a node, and if you see a bracket right after, that means okay, those are the children. So of that node beforehand. So you can see here it's B, and then E and F over there. And then I can see F has a K in here also. So we would have one for that. C,
Okay.
it doesn't really have anything. What should we do when we encounter an empty like a leaf node essentially? I guess we can just leave it empty. But then it might cause a case when we're trying to deserialize. Like, is it just the child? No. Okay, no. I think that's good. Yeah, we can leave it as a C because generally when we're iterating left to right, we see that B, is a bracket, and then the opening brackets will have a closing bracket, so we know we're done iterating over the children of a particular node. So C, D, and then D has children I, G, H, J.
Yeah. Okay.
So I think this is generally how we can. This is a general format we can serialize it in.
Sure.
So essentially, if child put. Okay, no. I think we can. Let me take a second to actually think about how we're gonna say this.
Okay.
So okay. So general idea is brackets for child nodes. This is gonna be a bit confusing. So generally, we have the format is node bracket if child over here parent child of parent. So that's generally the format of how we're serializing it.
Sure.
So parent child of parent. So let me take rid of that. So how are we gonna put this into code then for pseudocode? So we know that when we traverse a NRA tree, the format will probably be let's just go for a particular node, right? We'll have all the children that the particular node has. So that will probably just be an array of nodes then, I guess. And then, the value of the node. your node. So and that's how we go. So from this format, it looks like our traversal will be DFS
Sure.
because we're traversing all the children of the parent first.
Mm-hmm.
So instead of whereas BFS, we're traversing BCD, so that would give us not traverse the children before. So we would
Sure.
stick with DFS for this. So after that, let's define how we're gonna put a DFS for this in pseudocode because it's now an RHP, essentially a graph, but
Sure.
no cycles. So let's start at the root. No, let's define a function. No, let's put it in pseudocode. So basically, at each step, what we're gonna do for at each node, we would do the following. So basically, we add a node. Let's add the node to the serialization string.
Mm-hmm.
So now we're just we're talking about serialization currently.
Mm-hmm.
So basically at each node we would add the node to the serialization string that we have, and then now we would traverse the children of it to follow our format. So
Okay.
I guess for each child node,
Mm-hmm.
for each child of node,
Mm-hmm.
we would need a way to define whether it's child or not. I guess we would try putting a bracket in here, add bracket in serialization string here, but that would mean that wouldn't fit our format. We would essentially have A and then B, E, F, like that format. No, so that wouldn't really fit our format over here.
Mm-hmm.
So I guess we can have an if statement over here. If a child of node exists, we would then add the bracket over there, and then after that we would traverse over the child nodes. So after that, we traverse the child nodes. Repeat process. Okay, let's go visit the child node. So when visiting the child node, we essentially repeat this entire process again.
Okay, sure.
After that, we're done adding in our children. We would add the end bracket now. So add in serialization string, and that should be the general idea for our serialization. But let me test it first to make sure that it actually works. So let's start with the example tree that we have first. We have, so first at each node, right, we're gonna start at the root, of course. So start at root. So essentially it would be A first, then so we add the node to the serialization string. Now we check if a child of the node exists. So we see that has BCD, right? So then we add a bracket over there. Now for each child of node, so now B, we go B, so we visit child node. So we're gonna traverse left to right, of course. So B would be the first child we visit of A. After that, it would be B, so we add B to the node. We know that B has a child of E and F. So after that, we traverse those children over there, E, and then we visit the child node of E. It doesn't have any, so we wouldn't really add anything to it. Then we have F over here, and after F, it has K, so then we visit K, and after K ends, we know that it has no children, so okay, we get the ending bracket there, and then after that, the E also finishes too, so we'd have, we're finishing traversing all the children of B, so that would also be an ending bracket, and I think the general algorithm falls for everything else, so we don't have to repeat the examples for that. So yeah, I think we can start getting into the code idea now. No, we had to fix. We had to design deserialization first before we should actually design
I
it
would,
right out.
let's write the code for serialization first, because one doesn't really have that much impact of another, if especially if you have this right. So go ahead.
Okay, so yeah, okay. So basically, let's define the actual node first of how a node will look like. You know, value, children. You know, we have self.val, basically this dot val over there, dot children. Yeah, that's generally how a node will be defined. We don't really need any other information for us currently. So now let's define the method for serialization. We're taking the root of the tree, right? Because if you give us anything else other than the root of a tree, then we can't really. I mean, we'll deserialize everything beneath it, but we won't deserialize the entire tree. So
Just just write the code for it. It should be very simple.
Yeah, I'm gonna write the code now. Okay, so at each step we had to go to the serialization string. So let's define the serialization string. Well, no, yeah. So let's have the serialization string. It'll be a global variable essentially. So node.val. It'll be a string. So we can convert it to a string method over here. Oops. So if a child of node exists, so if node.children over here, after that, serialization over there. Now for child in node.children, after that, serialization child. After that, serialization that, and after that, we just returns the big serialization string that we have over.
Yeah, fix this one.
Oh yeah, my bad.
Yeah.
Okay. Yeah. So that's the serialization methods. So
Sure. All right.
Let's go on to the deserialization method then, since it won't affect too much of each other, and generally the code is out. It doesn't seem like there's any. It seems like it generally follows the idea, and I have tested it, but
okay, so that's fine. I think you tested it just fine. So
okay,
what I want you to do is now do the deserialize.
Yeah, so deserialization. Let's start the pseudocode ideas over here. So deserialization. So essentially, let's bring out the result string that we have. So imagine we're getting the input is this. So now we have to deserialize that tree. So obviously, let's copy paste the string again. I mean the tree again, just to avoid moving the screen too much. So over here, so that's generally the serialization we're thinking of. We need to deserialize it. So
okay. So how do you want to deserialize this?
Yeah. So we know, we just iterate through the string left to right now, but we know now when opening bracket, that means there's children to be dealt with, and closing bracket, that means we're done initializing the children of the parent. So let's go over the format once again.
I mean, I don't even need to go over the format. I already know that you set this up. You don't need to say it again, dude.
Yeah, I mean, yeah, it's just okay, just clarification, I guess.
Sure, whatever.
Okay. So if we iterate, so an idea is to iterate through the string left to right. So we have, and then create a node for each character we see. So in this case, it would be A. So we create node A first, and then we see an opening bracket. So then, okay, that means we have to create children of A. So, we basically just go iterate. We iterate until there's a opening bracket again, and add that node to the node.children of the parent. Let me write an example first to make sure this works out. So in node format, A would be this, and children of A is B, C, D. So when we go through this, we would add B to the children. So yeah, add B to the children. So over here, that would be B, and then go over that. See, counter B now.
Yep.
And then now we encounter another bracket. So now we have to input the child of B. So for a B node, children would be E first. And then E. So we have E over here. We know F is like, so then we go to F. Afterwards, we know that F is, you know, that means there's no children of E. So now we add F over there. We go into another opening bracket. So now we know F is our parent again. So K. So children, K. We know closing bracket now. So our parent can change back to B. And then we have closing bracket again. Yeah, so then that generally means we're done traversing F, and then back to B.
Okay.
And then now we're on to C now again for traversing through the string. C is children of A. Yeah, so generally this follows the same format. So B, C, D over here. And then D, you know, it has children I, G, H, J. So, when we're parsing strings like this, I feel a stack would be a pretty good data structure to utilize.
Sure.
Because we push in a string, we push in a bracket, we then analyze all the children out of those brackets.
Wait, are you pushing this string into the stack? What? Or
yes. Oh yeah. Let me clarify that. So we would push the entire string onto this. Let me clarify how we actually use a stack first. Like try an idea. The idea was just to use a stack since we are traversing through the string like this, but let me clarify how we're actually going to use it. So what happens if we do push in the strings? I mean push in every character. So
okay, well, let's clarify.
okay, no,
this.
we will push in just the brackets for the stack.
Well, let me ask, what benefit does pushing a bracket into the stack have over just iterating over the string? Like you said, you're iterating over the string. Why do you need the stack?
So we can identify if whether it's a opening bracket, the last element in our stack is a opening bracket or a closing bracket. If it's a closing bracket, that means we're done with the parent. If it's still an opening bracket, that means we have to process the parent again.
Sure, but does that mean that you need to put the bracket in the stack itself?
My idea currently was, you know, if it's a matching bracket in this case, then we can pop those two out. But I guess
what benefit does that give you? Why can't you just do the same thing with traversal?
Yeah, I think we can do the same thing with. I don't think we really need a stack. I think that was probably.
You might need a stack, but I'm saying that you might not need to actually put the open and close brackets in them.
Oh, I mean, okay, if we encounter a bracket, then we can push the children before that bracket. What happens if we put the children after the opening bracket. So
Okay.
in this case, let's go for A. No, let's go for node B. Let's try this out. Example for node B.
Okay.
So we have B. We
Mhm.
have an opening bracket. So that means let's push in the nodes E and F in there.
Okay.
Um.
Oh, okay. Well, why? What? You are gathering children. Why do children? Okay.
I mean, yeah. This is just me trying to test out the idea so far. So
All right.
if we opening another bracket, if we encounter another opening bracket now, then that means we add everything in our stack to the current element. So B, the current parent. So B. So now children equal EF, and then we pop out everything over here, and then our new parent will become the last element in the stack. So that will be F.
Do you really need a stack to keep track of children though? Why not a list?
Okay, yeah. Yeah, I guess, yeah, we can use a list then, yeah.
Okay, so then where does the stack come in?
If the stack comes, I mean, then if we're utilizing a list, then I think our list can replace the stack. Because essentially we don't really need the pop and append operations of a stack particularly, because a
Really?
list would
Okay.
have the same thing,
Okay.
just the pop.
Okay, so
And
you're iterating through the string. You have a node B, you're gonna add E and F, right? And then you go into K.
yeah, so then we enter in K.
Okay?
That would essentially be children F. We empty the list entirely, like reset it, clear it,
Okay?
and then we add K to the thing again. And once
F?
we have parent equal F, and then now if we encounter a closing bracket, if we encounter a closing bracket, that means technically we're done with it. So
Okay.
we add K to it, reset the stack again. But then now, yeah, I mean, I guess
So then now what do you node are you looking at?
we're only looking at the opening brackets, really.
I said node.
Yeah.
What
Oh, node. Oh, yeah. Node we're looking at right now is just the C node, really.
Really?
But, I mean, no, C node,
F is a child of B.
yeah. Yeah, F is a child of B. But we already, added the children of B to E and F.
So okay.
Yeah, because as we go left to right, then we made the nodes E and F, and we added them to B already.
Okay.
And then once we encounter the new parent, and then once we go through a new level, we see F over here. We add K to it. And then we add K to the child of F.
Okay.
So if we encounter C next time, over here,
Okay.
and we have an empty string, empty stat list, it's not really anything. So yeah.
So then where C attaches to A, how can you tell which node you need to attach to then?
Okay, yeah, there we go. Yeah, okay. For this case, okay, for this example, since I assumed B was the entire tree, because I started with B example, but if I was starting with A, then I guess A would always initially be in the stack then, if we add B, and then we add E and F.
Okay.
To
so
it.
you're gonna add every single node to the stack. Okay. Why?
No, we add initial levels to the stack until we encounter a closing bracket. So we would have EF. As soon as we have K, we encounter the closing bracket, right?
Okay.
So that means we would pop the last two elements. Then
Really?
no. Deserializing is a bit. Yeah. No, because my original idea was okay. If we did pop the last two elements, then we know then parent equal f and child of f equal k. Then we append back f to our stack again. So then it would become a b e f because now our reference is now f because now f has a child of k. I mean, generally we could just do the last element of our stack, add child, but I think popping and adding would fit better in the
Okay. I
operation
mean,
of the stack.
you probably will need some popping, but it's like, I think you're confused on how to actually handle this.
Yeah.
So, what exactly do you need to push and what exactly do you need to pop? Let's define that. And what exactly are you doing with the list?
Okay, so I need to pop all the children of a parent node.
Why? So you're okay. So you're gonna put
Yeah.
every single node into the stack, regardless of what needs to happen to it. Okay.
I mean, I would pop all the nodes in a particular subtree. Yeah. So in this
Okay.
case, it would be the left subtree of A.
Sure, but then how do you know that you're popping all the nodes of the children?
Yeah. Yeah, I guess I need to handle that. Let me go back to the design a little bit of how we're actually iterating through the. So we're iterating through the string left to right. That's
Okay.
like for sure. We
Okay.
iterate
And
through
so
the
the thing is that you're putting everything into a node, and you're also putting everything into a stack. I don't understand. Let's define what exactly the purpose of the stack is.
The purpose of the stack is just to identify whether if it's all the children of a particular parent.
Okay, so you're gonna use the stack to identify the list of children.
Yeah.
Why does that work? So if I'm looking at B, I look at A and I'm looking at B and I look at E and F, right?
Mm-hmm.
You're saying that you're gonna put E and F into the list of children, into the stack, right? But then how do you know what E and F belongs to? You know, just by this arrangement, you said, hey, I have all the children, and subchildren. But then B, E, and F could be a children of A, based on what you just did here.
Yeah. Okay, so the thinking was a bit wrong. Let's go back to the drawing board. So the stack was originally to list all the nodes of particular parents. So what happens if we have separate lists for a child? But every time we encounter a bracket, we'd make a new list with the next node. No, that would be a bit too weird. So because then we'd have
Okay.
like EF here, then like NK here. That would be a bit too messy.
Okay.
So let's scratch that. Let's clean this up a little bit. So E, we come to the bracket, and then becomes E. After that becomes F. So we know A is like the first node we encounter will for sure be our root node. So
Right.
root equal A. How do we then process the children of the children BCD? Originally, what we could have done was, I mean, a really dumb way of doing it is essentially we traverse our string for all the nodes that are currently not in the high level brackets. So in this case, you see our string would have BC, we would just have BCD because B has brackets over here and D has brackets. We would just be adding B and C and D. But that's kind of inefficient because then we have to, for every single character, we would have to have a find operation. So that would just be n squared
Okay.
for that.
I'm telling
So
you right now,
fine.
you can do this in order N.
Yeah, for sure we can do that. Because our serialization was essentially O of n, so our deserialization shouldn't take longer. unless like you do some fancy encrypted stuff. But this is just a deserializing and deserializing. So we know that we can improve it somehow to utilize the brackets, like essentially traverse our string like we traverse a tree.
Sure.
So A, then we go B over here. So let's define the relationship between these two first. How would we handle the relationship between a bracket, and a child? So what would we do for this? So if we had an array list or stack, like just essentially a sorted collection. If we add B over here, then if we have a variable keeping track of the parent, maybe A, but then if we encounter any children, such as E and F over here, then we'd have to erase B. So we have to overwrite A with B, so that wouldn't really keep tracking of which parent is which.
Sure.
That might seem a little bit confusing, but
Yeah, you are completely confused right now. You have no idea what you're doing. So,
I'm just trying out thinking of ways of how I can start.
Let's clear the table. What exactly is the problem that you're trying to solve?
Making sure that the deserialization of the string that I'm given, assuming it's an NRE tree.
Okay, so what is preventing you from actually solving the problem?
How would I parse my serialization string?
You're going to be iterating through it, right? So
yeah.
Be more specific. What is preventing you from not just running away with iteration?
How would I be keep tracking the parents of the children while I iterate from left to right?
Okay. So you need to keep track of the children, right? So why don't you start with a very simple example of A and B, like A is the parent, B is a child. How would you do that?
Yeah, like in this case, essentially.
Yeah, how would you do this?
Yeah, that's what I'm thinking is. Okay, like our initial parent is A, and then once we encounter a bracket, then we start doing A dot children equal B.
Okay.
And then as we go through it, like add next in their string, essentially it would be another bracket again though. So then we would do the previous node, so then it would be B dot children again.
Okay.
And then we would have E. Let me just copy that again. That string. So okay, yeah, we'd have B, and then F over here. So then we know B, E, and then F will become the children.
Sure.
But then we encounter another opening bracket again.
Okay.
So that means we're now traversing F. So F dot children equal K.
Okay.
And then now we do the closing bracket. So the closing bracket is what I'm having a bit of difficulty dealing with.
So what does the closing bracket represent?
We're done traversing a child. We're done traversing one parent.
Okay. We're done traversing the F, right? The F's children.
Yeah.
Now we're back on F.
Yeah.
And what do I do? And so let's say, like, for instance, I have a X here, just out of example.
Mm-hmm.
What would happen then?
Yeah. Then X should be the child of B.
Okay.
Yeah.
So how do you know what to assign it to?
Yeah. I guess that was where the stack idea came from.
Okay, but what? Yeah. So we're gonna need a stack, but why?
The stack to keep track of the parent node.
Sure. So in other words, you're not keeping track of every single child. You're keeping track of
The parents, yeah.
Okay, so in this case, what would the stack going through this? What would the stack contain at what points and why?
So let's go through the string again, like for our steps. So in this case, the stack would contain A. In
Sure,
this case, the stack would contain just the B. I
just
think
B.
in this case, the stack would just contain F.
Why just
No,
F? Why just those?
just those because we're keeping track of the parents because then,
Okay, so you're gonna keep
uh,
track of the parents, but then what
yeah.
happens when we're done looking at F? How do I get back to B?
Oh yeah, okay, so maybe I did this a bit weird. So A, there, we add the B now because B is now the parent. We basically add children to stack. Just last element of stack. Last element of stack. So in this case, it would be B. And then A, B, F here. We would add the children to K. I mean, add the children to F. Add children to F. And then once we encounter the closing bracket, we would pop F from it. So it would be A, then B. And then we know if we encounter an X near it again, like an X in this case, then X would be a child of B. So yeah, X would be a child of B. So then, what do I do this? So yeah, B dot children, E F X now. But if we, and then once we encounter another closing bracket, we would we would pop it and go back to A.
Okay, seems
So
reasonable.
I think, yeah, I think that's generally how the algorithm will go then.
Okay,
Essentially, the stack. So let me rewrite this an idea a little bit better, so we can actually keep track of all the progress we made so far. So
okay,
stack will contain the parent nodes. Iterate through our string left to right. Better way to do that is for each character in string. Yeah, create node if node is not a bracket, because we could essentially use something other than A, B, or C. Like we could use numbers for something, but numbers would be a bit difficult because then there's multi-character numbers.
Okay.
So let's just assume that it's. Can I assume that it's just characters for now, like capital letters?
sure. Let's just do one letter for now.
Okay, so yeah. If node is a character, then add node to stack. And then if we add the node to stack, after that we would let me redefine it. If character is a capital letter. Okay, no. I mean, I think you get the gist of it. No, that should be a little
That
bit
should
more.
never be something
Yeah.
you tell some.
Yeah, my bad. Let me go through it again. So, reach char and string. If char is an alphanumeric character in the alphabet is a character in the alphabet. There we go. Then create node out of char. Add node to stack. And then if char is a character, yeah, okay. Add the node to stack. After that, we would then if we then now we have to see if it's bracket next. But yeah, so else if node is a bracket, opening bracket,
Mm-hmm.
then stack, last element, a stack dot yeah, so then I guess we could set the parent to stack -1, like the last element of our stack, and then else LF node is a closing bracket. We essentially pop from the stack. Yeah, so we would pop from the stack. Yeah, so we pop from the stack over. Let's go back to the design again to make sure. So F, add the children to F. Yeah, we pop the F from the stack, and then it turns into B. So yeah, okay, yeah, pop from the stack, and then now we have to figure out the case where this is actually a child. So add node to stack. So if stack is not empty, then in this case we will be stack. No, that's not right. Okay, so my problem currently is finding out how are we going to append to the stack. So we know to append to the stack, like the parent is A.
Okay.
If we go back to the original example, when we encounter an opening bracket, we would then we would then assign the parent to be the last element in the stack. So then if we go to B, so B over here, and yeah, so we have B, add that to the stack. No, so we have A, create a node. I don't think we add this node to stack here just yet. Instead of here, we would, if it's an opening bracket, we would add the node to stack. But how would we keep track of what's the previous node that we currently have?
Mhm.
So we would maybe have a variable to keep track of the previous node that we encountered so far. Because since this is an LS, so yeah. Create a reference to node called previous, I guess, and then add previous to the stack. As soon as we add previous to the stack,
Okay.
now we have the case where we're adding to our node. Alright, I mean we're adding to our stack properly.
Well, you already covered all the cases, right? The characters and alphabet, and then open bracket and close bracket. So.
Yeah. So now when we encounter a bracket, I think we pop in the stack, create a node. So now we have to actually add the children of the nodes. So
Okay.
if characters an alphabet. Yeah, so I guess what we can do is if node, let me define these a little bit better. If char is an opening bracket, if char is a closing bracket. Now, so we can say if char is an opening bracket, then add all the next node. No, I mean essentially we want to do if it is a opening bracket, then we add all the next nodes until we encounter a closing bracket. So
okay,
maybe over here we would have a while loop, or until it's
okay. But then doesn't that defeat the purpose of this alphabet scan?
Yeah, that does. So I'm a bit wary of adding it. If character is a character in the alphabet, we create a reference node to node called previous. As soon as we add it to stack,
But then, and you open bracket, you create a node. So then, my question then becomes, okay, what happens if you encounter 2 characters?
Yeah.
What do you want to do?
If we encounter 2 characters, so in that, let me define that test case really quick. So A B, and then let's just have.
Well, you already, yeah, you have bracket, and then you have like A, B, like C, D, E, or whatever. No, nothing.
Yeah. Yeah. So as soon as we encounter A, we see that it's an alphabet. We create another car, make that A previous. So that would be A over there, and then we go on to the opening bracket. So now we add previous to the stack. So that would just be A over here. And then now we go on to B. So B is technically this case.
Okay.
So B is now a node of our char.
Sure.
B is now a node. But now we need to make sure to add B to our stack. So maybe we can say if.
Why do you need to put it in the stack?
No, we don't need to put it in stack. But I'm saying that now that our stack is defined.
Okay.
Now we should add B to the children of the last element in our stack.
Okay.
So if stack is not empty, then stack, the last element of our stack, children dot add node then. And then now we go on to C. So that would handle that case. So now we go back to C. Over here we see C. There's no opening brackets, so then we'd add A back again. Since A is still the only element in our stack. So it would be C. We go through it again. Now we're on to D. So our stack would then, our A would just have dot children will become BCD now.
Sure.
So that works because then we have our pop from stack after. We pop A from the stack, and that's generally good. That we're done with that now, and we just return.
Yeah, I think that works. So yeah, why write the code for it?
Original node. Yeah. Okay. Let me test the case to make sure that when we have nested parentheses.
Sure.
So let's just define something really simple. E, for example. So let's go back over here. So let's start from the beginning. A. Yes, we add it to the stack. Go through it again. Characters and alphabet. Now we create a node out of B. B is fine. We start with B again. And now we have an opening bracket. We add it previous to the stack. So that would be B. And then, opening bracket. Yeah, we call it opening bracket. Now it's E. E is, we create a node out of the char. Stack is not empty. Yeah, so then it would be, we add B. So then B dot children equal E. Closing bracket, we pop in the stack. Yeah, no one really cares anymore. And then about B, and then we already processed C and D the right way, so it works then. Okay, so let me write that out into code really quickly. So generally, it's already there. So let's define the function, the serialization. We're given a string serialization. Whatever, variable names, can change that later. So for character in serialization, so for each character in the serialization string, so we'll initialize a stack first, carry everything. So for character initialization, so if char is in just a really really way, you get the idea.
Okay.
This is basically the alphabet.
Just write your code, dude. You're at 49 minutes, by the way. So.
Okay. So let's do that really quickly then. children dot add append. Yeah, node. Let's define the nodes. So node equal character, and yeah, that'll be fine. So yeah, and then the children would just be empty. So if not staff, create a reference node. So previous equal node. Oops. Damn it. Okay, so yeah, that's how it goes. Previous, and then elif char character equal opening bracket prev dot stack dot append previous. After that, if the character is equal to a closing bracket, stack dot pop. After that, we return the original node that we had. So maybe we can just have a pointer to the original node really quickly somewhere. So because we know our stack will be empty by the end of it.
Okay.
Wait, will our stack be empty by the end? Yeah, it will. So let's just have root node equal none, and then basically if not root node, let's assign root node to node, and then just return root node over there, and then yeah.
Okay. Let's see. Character is in. Okay, sure. Node, if not in stack, then children at append. If not root node, sure. Yeah, I think that's right. Okay, cool. All right.
Yay.
What do you think you did right? What do you think you did wrong?
So what I did wrong was essentially when I had no idea where to go. I was trying out a bit too random ideas. I wasn't probably defining what I wanted in my stack. I was just putting in random things, like unstructured way of putting in things into my stack and hoping one of those ways clicked. I should have defined exactly what I want. Like, do I want all children in my stack? Do I want all parentheses in my stack, and try out a test case for each of those to see if it would work better, or at least think about the idea if it would work better, instead of think, okay, let's just try appending a bracket to the stack. Oh wait, no, maybe we should try appending a node to the stack. Maybe define like a proper way to what to add to the stack first.
Yeah. Basically, that's one of it. I had to literally drag you through that thinking. I was like, okay, well, what's preventing you from solving the problem? I was like, okay, you can't do this, you can't do this, you can't do this. And so remember the detail of like, oh yeah, well, why are you, when you walk through it, like, oh yeah, I need A, B, A, B, A, B, F, or whatever. And I told you, wait a minute, why do you need to put in B and F at the same time as well into the stack? How do you, and when you pop out of F, what is the last node that you need to look at? B. That was it. That's all you had to ask yourself. That was all I walked you through. And then you realize, wait a minute, in order to get that, B should be the last element in my stack. Oh wait, I don't need to put all the elements in. So in other words, the mistake that you made was kind of doing this shit in your head, I guess. It's partially, but also there's a more cardinal sin, I would say. The first one, let me paste my notes. I would say the first 15 minutes are fine. Like, I think that you went to you wrote when you're writing the code for Deserialize, you just talk way too much. So you already talked to the idea. Yeah. You already got it. Just write the damn code. We don't care. That's a small thing though. Okay. But going through the Deserialize. Let's see. I would say the first thing that matters is that you need to start with simple examples.
Yeah.
Remember? I think. Go ahead.
Yeah. No. Yeah. And the simple example I was doing, in my case, for this example, problem was the test case you given me. But what I should have done was, just A, B. Just like what I started with, because the idea started clicking as soon as I did. Okay, well, it's just A opening bracket B. Yeah. So it started clicking then when I tried the simple case. Yeah.
Yeah. So in other words, start with a very simple example. I think you made this mistake before.
Yeah.
So in other
I
words,
think
you made the mistake again. You made this mistake before. You forgot about it, and it's happening again. So there's a problem.
Yeah.
So
I think
I
more
mean,
like-
I don't know. Like, what was it about the previous mistake that you didn't feel like you had to remember?
I mean, yeah, that I was definitely remember. I think in this case is because I know that one string, like I properly serialized one string. So let's properly try and find out how we can think about the test case for that. I think my simple test case was a bit too complex. I should have. It was
Yeah.
basically it didn't hurt enough, I guess, last time.
Yeah. So now you're making this fucking mistake again. I'm gonna like you should not be fucking making this mistake. You have 1 week. You know.
Yeah.
So why the fuck is this happening?
Yeah.
You're not gonna make this mistake again, right?
Yeah.
I'll be really fucking mad because I mean I already fucking told you like start simple, start with a very basic test cases, make sure your idea works, and don't like and when you try doing too much at once, you couldn't see it. And all it is a question of what am I doing wrong? Why can't I get through the problem? And then just starting simpler and simpler and simpler. Just backtracking like okay maybe I'm taking on too much, and you should be able to start with a simple example, or at the very least understand why can't I make progress. And if it's not clear, start simpler. Start with a subset of the problem.
Yeah.
So, in other words, you already know what you need to do. You've already made the mistake. You already know what you already knew. You've already made the mistake before. So the question is, are you going to actually remember that? And most importantly, are you going to be able to prevent yourself from doing that? And so at that point, it's just like, it's like we've gone through this before. I don't know what to tell you.
Yeah, I mean, yeah, it's just a matter of putting into the structure. Like, I think, so, yeah, when I approach a problem, what I usually try to do is, if I don't understand it too well, then I would probably try to solve the test case they give me first, and then try maybe a simpler test case if I can't come up with a test case. Do you think I should try, initially say, hey, does this test case also work? Like, is this also a valid test case to the interviewer, and like give out a really simple test case?
Yeah, I mean, in general, it's like, hey, I'm still confused. I want to try poking holes in my understanding. Let me try very simple examples where I might be able to poke holes in. Yeah, that's perfectly fine. Like, I mean, let me make sure I really get it by making sure, like, I'm not misunderstanding it. You know? And also, like, oh, I need to solve it. Let me try something simple. Simple is better. Like, in 99% of the cases. Google wasn't built in a fucking day, okay? Like, if you know the story of Google, they literally, like, cobbled their fucking backend together by buying used hardware. They started fucking simple and with the worst case scenario planned in mind.
Yeah, jeez, yeah.
I'm actually not shitting you. Like, the fucking hard drives had like 10% failure rate, right? So they weren't like gifted like some fucking like god tier new shit when they were starting out. No. They were working with like fucking like dumpster tier hardware, and they still made it work because they assumed the worst because they basically had to live with all the worst things. So. In other words, you should be thinking the same way. What can go wrong? Let me start very simple. Let me solve a very simple problem. And maybe make sure that my simple solution to that simple problem is bulletproof before I grow and move on. So
yeah.
That's what's happening here. Other than that, like, you know what to do. Your problem solving was fine. It's just a little bit slow for my tastes. But it was logical, as simple, as straightforward. That's what we care about at this point. But again, most of the slowness comes from the fact that you did start simple and grow your problem and grow it from there.
Okay, yeah. So let me see, if I did start out simple, do you think I would be stopping around the 30-minute mark then, I guess?
I would probably guess about 40, 35 more like, but yeah, because, like I said, you talk too much during the code, so that adds on another, like, 5 minutes. But yeah, I would say 30, 35 minutes is actually pretty good, like, for solving this problem. Usually, people solve this in like 45, but you solved it in like 55. So, and 10, 20 minutes of that was because you were screwing up by not doing simple examples.
Okay, yeah.
So you could have gotten it down to like above average if you literally just didn't make that one mistake.
Yeah, always that a tiny one mistake that always pushes everything.
Yep.
To the end. So yeah.
I told you that. Like, it's literally every single person. They make one mistake in their thinking, and that kills them for the rest of the interview.
Yeah.
So in other words, don't make
Yeah.
that mistake because
Yeah.
it's not a matter of oh this mistake isn't going to come up like it's only going to come up like 1% of the time or 0.1% of the time. I don't have to care. No, no, no. It's the fact that you only have one chance right now. You have one interview, and anything can happen. And if you make that mistake, it blows you up.
Yeah, and we don't want me blowing up.
I don't want you blowing up.
Yeah.
So that's basically what I got for you today. I mean, we can do. I don't think we have enough time for doing another problem, but basically, all that's left is for you to refine that approach and really, really study your mistakes. That's all I got. Like look at every single mistake you've ever made, and just really, really hammer it in your head, and feel like shit about it, like, and recognize it. You know.
Yeah, definitely do feel like ass after not doing that simple case beforehand.
Mistakes, and then like the whole all that's left is really just to, since it's on the 27th. You have a 27th onsite, right?
Yeah, onsite.
Okay,
Yeah.
okay. So we actually have 10 days to it. Okay. So what I want you to do is like start doing. You did the honor. Have you done the honor classes?
No, I actually have not started the honor classes because I'm not done the entire EPI yet.
That's.
But
I'm
can
gonna say
doing
start
honor
shifting to honor classes right now. We have 10 days. So I want you to spend the first of everything this weekend and up until Tuesday doing the honor classes.
Okay. That
Yeah,
works.
on EPI, and then after that, I'll have you do the leak code. But don't get to leak code just yet.
Okay. Yeah. No worries.
So, because that'll give you like 1 week of trying the Google tagged problems. But yeah, it's basically we're trying to speed you up right now. I get your point of doing like the pseudocode and before you do the design. I think it helps you, so I don't have a problem with that. But I expect once you do the pseudocode and you refine it and test it, your code should be very instantaneous. That's all I ask is that if you're gonna do that and have bulletproof the idea and do the pseudocode, at least don't piss off the interviewer.
Yeah. Make sure it's bulletproof and really fast typing out the actual code. Yeah.
Correct. That's all I ask, because like if the interviewer sees you like doing the same shit over and over again, he's gonna be like rolling his eyes and like whatever. He's gonna go surf on Reddit, you know.
Yeah.
It's like I've already heard you do this before. If you need to talk out how a stack works while writing the code when you've already tested it, something's wrong. So in other words, it's the speed that matters.
Okay. Would you say that after in this case the pseudocode, let me bring out the problem that I had again. So yeah, where is it? Problem 3. So yeah. So for the pseudocode, did you think did I take too long in the pseudocode this time? Like after yeah, do you think I took too long in the pseudocode this time?
Let's look at the timestamps. So I would say that coming up with the idea was the difficult part for you.
Yeah,
and then I would say, if I recall correctly, once you got the idea down, then you write the pseudocode. Took you like I want to say like 5 minutes, 7 minutes, and then you wrote the code in another 5 minutes. So I don't know a problem you spending like 7 minutes on pseudocode if it means you write the code very quickly in 3, and not talk so much about it. Because if you look back at like what you did, right?
Yeah.
It's not very difficult.
Serializing and deserializing?
No. I'm talking about like let's compare like your code to the idea that you got going.
Okay, yeah.
This should have been like you only wrote like 10 lines, but it took you 5 minutes to do it.
Yeah. Yeah.
So I'm
the pseudocode I think took me a lot longer than the actual code. The actual code was a little bit
but your code itself, the line that I've highlighted, took way too long compared to the amount of time that you spent on the idea. The idea should be like fucking bulletproof and shit, right? You spent all the time like finagling with it, trying to test it, whatever. It should be an immediate translation to it, right? So it's like, okay, I got the plan, I make sure it works. So all I need to do is like stack will contain the parent nodes, right? So I'm going to create a stack, right? And I have a root node, right? And I'm going to iterate through every single character in the serialization, and the character's the node of the alphabet, create the node out of the character, and then stack's not empty, and then assign to root. So you should have made that mental node with a root, or at least like wrote it down somewhere. Create a reference to node previous. Otherwise, then attach to previous or whatever.
Yeah.
Like literally, if I did a 1-for-1 translation of your code, the only thing I'd be missing out on is really just this, if not root node equals node.
Yeah.
So my question is, if you're like fucking messing around with the code implementation like that, it means that you're not confident in your idea. or you
Yeah.
don't or you're not able to translate the idea to code very easily, which means you probably need to like go back to fucking freshman year of college.
I hope
I don't know
not.
which one it is, dude.
Yeah.
I'm gonna bet more as the confidence thing. So that means that you need to bulletproof your idea and test it a few times, I guess. But starting with very simple ideas, I don't know. At this point, it's like I'm not quite sure.
Okay.
It's like maybe have a little
Um.
bit more faith in your plan, and if you don't have faith in your plan, make sure the plan is bulletproof and solid.
Yeah. I think I should have been a little bit more thorough with my testing of the thing.
Yeah. So instead of like trying to like fucking finagle the code, make sure you test your idea. And of course, you came up with the A B C D E, right? So this I would say
Yeah.
representative of pretty much every single what's it called every single test, every single code you're gonna come up with.
Yeah.
So it's like what's left, you know?
Yeah, that's true. Yeah. And then I think instead of it return original node, I should
I
have.
will also say that there is a small bug,
Oh yeah.
and you do need to test it because remember what happens if I have put what if I've what if letter after letter, then you overwrite the oh wait no you actually put the never mind you're good actually I screwed up no you're right if not stack you put in the there actually you're fine yeah so it's like you pass that test case right and that's pretty representative of all the things that you're gonna run into, so to me I'm just like I'm not quite sure what's left like
Do it
where's
faster.
where's the hesitation coming from?
Yeah.
It's
I
about like
mean,
convincing yourself, I think. So
I'll say that again.
it's about convincing yourself that you've covered
Yeah.
all your test case is representative of everything you're ever gonna run into.
Yeah. Yeah. Probably. Like I'm always a little bit careful when implementing my code. So like, oh, I need. It's like I'm because even while I'm implementing the code, I feel like I'm still thinking of a test case that I didn't have installed yet, sort of thing.
Sure. I mean that's gonna happen, right? There's always a
Yeah.
little bit of paranoia about it, right? But the thing is that you should have gone over like 90% of the paranoia in practice because you thought of structuring your test cases in a way that covers all the possible test cases you're gonna run into. So.
Yeah. Okay. Yeah.
So this is where like paying attention to your practice and really making sure that you actually that you take your practice seriously and you remember every single mistake that you make and what worked and what didn't. This is where like you're being really meticulous about your practice matters. So
Okay. Yeah. I think I'm starting to see that. Yeah.
so this is why like I've been like I've been harping on you about this shit. So okay.
Yeah.
Anyway, so is there anything else I can do for you? Because I think we're pretty much yeah. It's like I've kind of explained everything. I don't. There's not enough time to do another problem, so
Yeah. I think. Yeah, everything's good. I'm gonna start doing the honor class of EPI.
Uh-huh.
And then, yeah, and then starting to be a bit more be more meticulous and watch some more video entries.
yeah. And it's really about at this point, it's not about like consuming other people's resources. It's about consuming your own resources. It's about literally looking at your own mistakes, and then getting what's it called, being super careful and care about what you're doing and what you are prone to, and really understanding like what your mistakes you tend to make. So
Yeah, like understanding my ticks.
yeah, exactly, and catching stuff. So that's all I got for you.
Okay, yeah. I mean that's fine. Yeah.
All right.
Okay.
All right. Anything else?
I think that's it. Yeah. Gonna. Yeah. Ready. Yeah. Basically
Okay.
motivated to do more questions and all that.
Yeah, and mostly study your mistakes, not just doing the questions.
Yeah.
It's like-
Yeah, for sure. Study my mistakes. Yeah.
Okay.
I'm gonna watch it. I record myself doing every problem. I'm
Yeah.
gonna watch the videos.
All right, we got 10 days, dude. No fucking around. This has to be like the #1 priority, and everything needs to fucking needs to go under the microscope. So
Yeah. Okay. Yeah. I think. Yeah.
Right.
Generally, when I do my practice problems, sometimes when I tend to go quiet, I'd probably just fast forward a little bit of that time until I hear a voice again. Should I still, like, look at the code a little, like look what I
what do you
I
mean
don't
you
know.
hear the voice again?
Until like I hear a sound from me talking it, because sometimes I go quiet, but I know in like well, because I'm watching the video, it was me thinking about the time at that time of what to do next.
Mhm.
Usually I just like go forward, like fast forward to the next part. I hear a sound. Like, what do you think I should do during that? Like when it's just like complete silence in the video.
Just say, hey, let me work through this. That's fine. I would
Okay.
say like sometimes it's okay to be a little bit silent. Especially if you're like making progress and you're writing it out. I don't
Yeah.
think anyone has a problem with that. If you just sit there frozen, everyone's like, "What's assuming the worst case scenario?" But if you're writing shit out on the board, hey, give me the moment. Let me try working through this. I think, and you start like writing shit out and testing things and like talking to yourself. It's fine.
Okay. Yeah.
Because besides, you shouldn't be doing things in your head anyway. You should be you should be writing it out, right? That's one of the things we
Yeah.
talked about. So as long as you're writing it out, I don't think
Yeah.
anyone
Yeah.
can
I'm
complain.
reading it. Yeah. Yeah.
As long as
And
you're
like
writing
when
shit
I
out, you're fine.
yeah. Okay. That's good. Yeah. 'Cause sometimes I do talk to myself too. I think you heard it a lot in the video too, but yeah, sometimes I just talk to myself. Do you think that's like okay, or do you think like the interview? I mean, get bored. I mean, technically, they don't really need to hear it because it's just me talking to myself. But I feel like the interviewer would get bored if they try to listen to it, and I waste too much of their attention span.
Mm. Okay. Yeah, it's fine. The thing is, like I said, about like it's about you being able to work through the problem, and honestly, as long as you're logical about it and straightforward, no one gives a fuck. And yeah, it's at the moment when you start pissing off the interviewer is when um, you should be worried. So
Yeah, let's just hope I don't piss off my interviewer. I hope I get a nice person or something. I don't even know.
no, don't hope for a nice person. Just hope that
Yeah.
you can do very very well, and that everything you've practiced is right. And make
Yeah,
sure that
yeah.
and most
My
importantly,
bad. I
make sure that
should've.
happens by making sure you identify every single little fuck up that can piss off the interviewer or make you inefficient or not allow you to solve the problem. So
Okay. Yeah.
all right, anything else?
Be meticulous and self-detailed. Yeah.
All right, sounds good. Then I'm gonna let you go.
All right. Thanks, Edward.
All right,
Cheers.
talk to you later.
Talk to you later.
All right, cool. Let's take questions from the crowd. Someone says to do a backflip. Can't do a backflip, bro. What else? If anyone has any questions, like, feel free to frickin' ask them. I'm just gonna be like,
Fucking butter pops.
I wonder if I should watch Dota or play a little bit more Emerald Kaizo. Actually, no. I said I was gonna do Emerald Kaizo, right? Well, I'll do like a few minutes of it. While I'm waiting for questions from the crowd. So let's see. Oh wait, this got oh, yeah, maybe I'll catch this. Screw it. Why is Cubone so hard to catch? Jesus Christ. Alright, well I have one Pokeball left. Oh, there we go. No questions from the crowd? Seriously? I mean, I guess I'll just stream Pokemon Emerald Kaizo. Sure. Don't need to repel, and I think I'm good. Yeah, good thing the mod actually lets me buy like, what's it called? Pokeballs for $10 each. That's actually so good. I might not even use all these, so whatever. Alright, then I'll level up the Cubone to level 11 just so I can, just so he's not like massively under leveled. Alright, I guess I'll stop the stream because I ain't getting any questions, so... You know what? I'll see y'all guys later, Tuesday, 8 p.m. Pacific Standard Time. How do you get so many rare candies in the game so early? I hacked it in, dude. I don't want to spend all my time, like, freaking, what's it called, grinding for levels. It's Emerald Kaizo, it's a hack, so... That, where the trainers are, like, really strong, so... I don't want to spend all my time freaking, grinding for levels, so I'm good, I'm good. Oh, crap. Alright. I'll see y'all later, guys. 8 p.m. Pacific Standard Time on Tuesday.